Just talk briefly about some of the economics research that we've been doing on bioenergy in Florida. This was a project that was commissioned by the Florida Department of Agriculture and Division of Forestry, specifically to look at the effects of various incentives and subsidies that are available for bioenergy producers in Florida. Because there was a big concern that increasing bioenergy production would pose a new demand on the biomass resources like forests and could create more competition for the existing forest products industry that uses a lot of these woody materials. So far we've been talking mostly about liquid and gaseous fuels, but of course the other big part of the energy sector is electric power. And I feel that it's probably even more important to get it right with electric power generation than it is liquid or gaseous fuels, because reliable supplies of electricity are really a key to economic development around the world. Most, indices of human welfare and sustainability take into account the access to electricity. Electric power utilities are the largest single use of primary energy and the largest source of greenhouse gas emissions around the world. And we expect that demand for electric power is going to continue to grow slowly in the U.S. and much more rapidly in the developing world. Here in Florida, we have very high consumption of electric power because of our demands for cooling in the long, hot summer months. And then looking ahead into the future, it looks like probably we're just now coming out with some of the first electric vehicles in the U.S. The Chevrolet Volt is a mass-produced car available now, and I think in the future we're going to be seeing a lot more electric powered transportation instead of fossil fuels. In the looking out over the next 25 years in the U.S., we're going to see really huge investment in bioenergy in the next 5 years. That's the green part here, and also replacement of natural gas for coal in the electric power sector. And this is the projected generation. Again, big increase in biomass and wind energy in the U.S. Not so much solar thermal and geothermal. Those are fairly mature technologies already. Here in Florida specifically, we're going to see about a nearly tenfold increase in bioenergy, electric power generation, according to the U.S. Department of Energy. The cost of electrical generation technologies is continuing to come down. So the bioenergy here is kind of in the middle of the range of costs, but it's the lower end of biomass is less costly than coal, for example, and quite a bit cheaper than nuclear. So we think that bioenergy is going to displace some of these other sources. Really the basic policy scenario that we looked at in our research was a renewable portfolio standard that would require a minimum percentage of electric power generated from renewable sources, up to 20% of the total mix of electric power by the year 2021. And that's a fairly typical policy. About 13 other states in the U.S. already have a renewable portfolio standard. So woody biomass is a widely available resource dispersed across the landscape. Typically has very low pollution emissions. However, it does have some drawbacks to it. It may be available only seasonally. It may have very variable composition, but sometimes lots of moisture or ash. And it's a very bulky material to transport. Very high transportation costs that typically limit it to being transported 100 miles or less. In Florida here we're blessed with quite abundant biomass resources. According to studies that have been done with forest data from the U.S. Forest Service, over 7 billion tons per year are potentially available. So you see here in Florida, with some areas, in particular South Florida and Central Florida, have very high availability of some of these urban wood wastes, the tree trimmings and landscape debris collected from homes and businesses. We, as economists, one of the things we typically do with this is to construct supply curves that describe the cost of delivering biomass at a different, at any different quantity. So you see here, as you go out, increase the quantity up, approaching 700, 800,000 dry tons per year. The cost slowly increases and approaches this line up here. But it differs across in different counties in Florida depending upon the relative abundance of the resource. But $3 per million BTUs is kind of a good benchmark cost. That's the comparative price of coal delivered into Florida. So as long as we can keep costs below this $3 per million BTUs, we think that biomass can be competitive with fossil fuels.
Question is delivered at the plant.
Delivered to the plant, yes. In Florida, we buy coal from Alabama and Kentucky, so it's transported several hundred miles to get here. And the transportation is a significant part of that cost.
But this cost does not include efficiency of technology.
No, it's just the dollars per
Okay.
heat unit content.
Incoming energy.
No, that does not include any taxes. And their coal is not taxed in the U.S. for commercial power production. Now that could change if we have if we adopt a climate greenhouse gas legislation. It could impose a tax on fossil fuels in the future, but we're not there yet. That's, of course, very controversial in the U.S.
It should be an alternative as well.
It should be. In my view, we should have done it a long time ago, but we've not had the political will to do that yet.
Chicken and egg story.
Yeah. So in our study, we did an economic impact analysis of the effect of increasing bioelectricity production up to 20% of our electric power fuel mix. I don't need to bother you with all the details of this. If you care to read about it, I can give you some of our papers as background. But just suffice it to say that we believe these models are realistic of how the economy works. Basically, we're representing how biomass fuels would substitute for fossil fuels like coal and natural gas, up to 20% of the total fuel mix. So we evaluated the renewable electricity standard, the 20%, and then various tax credits. There's a 1 cent per kilowatt hour state tax credit and 1.1 cent per kilowatt hour federal tax credit, and then there's also a federal U.S. government subsidy available for biomass feedstocks, up to $40 per ton, 100% subsidy. And these were the levels that we looked at, up from 1 to up to 80 million green tons that would represent less than 1% up to around 20% of the total electricity supply in Florida, projected out to the year 2025. So taking into account population growth and increased demand. And we assumed an average price of about $30 per dry ton of biomass, and so that would represent this up to $2.4 billion in additional income to the forestry and forest products sector of the economy. So these are some of our basic results. The change in gross domestic product, the broadest possible measure of total economic activity, the value of all goods and services produced in an economy. In Florida, the gross domestic product is about $720 billion annually. And if Florida were an independent nation, it would be the 15th largest in the world. So big economy, and so very marginal changes in economic activity in percentage terms can really represent a lot of money. These are the scenarios we looked at and the range of values we simulated with our model. For the kind of the mid-range value, with no subsidies involved, but mobile, assuming capital is mobile, that there will be new capital investment made to support expansion of the bioenergy sector. It would be an increase of about up to $5 billion in total economic activity, or around 0.5% of current GDP.